All right, we're going to get into our last kind of lesson of Unit 1. Then we're going to review and then take our, well, I guess we were going to take our test then. So if I'm looking at an inverse function, so again, kind of how it works informally is that let's say we've got a function, and again, our function is x plus 4. I'm going to say that this is the domain of f. This is x. And then we would say that, okay, if this is the domain, then this over here is going to be my range. And we're going to call that, this is my range of f, which we would call f of x. However, if I want to find the inverse function, I'm going to go and kind of do the opposite. So my domain of the first function is actually my range of my inverse. And my range of my original function becomes my domain of my inverse. Notice how we write inverse functions, f of -1. So in a sense, to find the inverse, again, very formal, informal language, we flip-flop our x's and our y's, okay? So I take my x values, I make them my y's, I take my y's and I make them my x's. So the question I'm going to solve first, so again, our first function is, we have the function f of x equals 4x. So I want you to find the inverse, and then verify f of the inverse, so the function of our inverse, are equal to the identity. So we want to make sure that these are going to be equal. So if I take my original function, I find the inverse. If I take my inverse of my original function, they better equal the same thing. So again, it's easier to kind of look at an example. So again, if my original function is f of x, what I'm going to do is I'm going to again swap out my x's. So this is my original function. My inverse is going to look something like x equals 4y. But again, I don't want that. I want the inverse. I want to get y equals. So how do I get y equals? Divide by 4, divide by 4. So we can say that our inverse function is x over 4 equals y. So these are our two functions. Now if we want to prove this, so again, thinking about what I wrote right here, my function of my inverse, f, like we practice composite functions, f of g of x, g of f of x. So every time I see my original function, which is 4x, every time I see an x, I'm going to plug in this equation. So equals 4, and then I'm going to say parentheses x over 4. And again, 4 divided by 4 is going to cancel out, so I'm going to get x. Now I need to do the same thing with my inverse. So take my inverse function, inverse of f of x. And again, that's this function, or that's this function that we just found right here. So every time I see an x, I'm going to write this one, which is 4x over 4. And again, 4 divided by 4 cancels out, so we're left with x. So we verified, hey, we got the same answer both times. So yes, these two functions are inverses of each other. We could do one more example like that. We're actually going to look at a table. So again, let's say that I've got a table and I've got x and f of x. I'm going to say I've got -2, 8, -1, -7, 0, -6, 1, -5, and 2, -4. If I want the inverse of this, again, all I have to do is flip-flop my x's and my y's. So again, my inverse function is going to be 8, negative 2, negative 7, negative 1, negative 6, 0, 1, negative 5, negative 4, and 2. I'm flip-flopping my x's and my y values. So again, like we kind of talked about up here, this is our actual definition of an inverse. If the function of our inverse function equals the inverse function of our function, we have an inverse. And again, we did one example where we proved it. We ended up getting x equals x right here. So we can prove this algebraically. So again, a little more complex example. Let's take f of x equals 2x to the third minus 1. And then g of x is going to be the cubed root of x plus 1 x plus 1 divided by 2. So if I want to find, so the question is, show that these two functions are inverse of each other. Show / prove. Well, let's do it. So let's find, again, if they are inverses, this must be true. F of g of x is going to equal g of f of x. So that's our goal. This is our goal. How do we prove it? Well, let's start with this one first, okay? So I'm going to start with f of g of x, which says every time I see my function f, which is 2x to the third minus 1, every time I see this x right here, I am going to plug in this entire function. So I'm going to say, all right, cubed root of x plus 1 divided by 2. And then again, this is all to the third power minus 1. Now it's nice because let's think about it. The cubed root to the third power, those are inverses themselves, and they're actually going to cancel out. So this is going to cancel out. So all I'm left with is 2, and again, it's still in parentheses, x plus 1 divided by 2 minus 1. Well, again, nice, because I see, hey, 2 divided by 2 cancels out, which leaves me with x plus 1 minus 1, and 1 minus 1 cancels out. Therefore, f of g of x equals x. Half of my problem is done. Now I have to go back and do the second part and hope that everything works out and we get the same answer. So g of f of x equals g parentheses. Okay, every time, if this is my original function, every time I see an x, I'm going to plug in 2x to the third minus 1. So I'm going to start by saying 2x to the third minus 1, which again is going to equal the cubed root of 2x to the third minus 1 plus 1 divided by 2 Now, again, I see, hey, I've got negative 1 plus 1, so those are going to cancel out. So I'm going to rewrite it as the cubed root of 2x to the third divided by 2. And I'm going to say, hey, 2 divided by 2 cancels out. Therefore, I have the cubed root of x to the third. And again, these are inverse operations, so they also are going to cancel out. Therefore, g of f of x equals x. Did we get the same answer? Yes, we did. Therefore, we have proved algebraically that these two functions that we started with, these two functions are inverses. So, copy, paste, move it over. Yes, they are inverses. Nice.